Yes.
Good morning. We're team number 10 and we're going to solve problem number 10.
So the data that we have is that the given position at time equals, this is the positional time at time t. Then we have the derivative of the position, which equals velocity, and its velocity at time t. And then we have the second derivative of t, which equals the first derivative of velocity, which equals acceleration at time is acceleration. Okay?
Now the given data that we have is first the initial velocity, which is velocity at 0, it's 40 feet per second. Okay? Then we have our initial condition of position, which is where we are at. And it's the position at 0, which is 200 feet. Okay? Then we have our acceleration, which is our formula, which is the second derivative. It's minus 32 feet squared per second. And then at last, we need to get the time when velocity is 20 feet per second. So we have to find t. Find time. To get our formula, first we have to know that our second derivative, which is acceleration, it's minus 32. Okay? So what we need to do is integrate with the first derivative, which is minus 32, t, which is time, plus c, the constant. Then we have to substitute the first derivative with 0 to get our c. So minus 32 times 0 plus 40, which equals c. This means that c equals 40. So now we can substitute our values, which is s of t equals minus 32 t plus 40. And this is our formula.
Oh, now I get it.
Now we need to find time when velocity equals 20 feet per second. Okay? So, what we need to do first, we know that our equation is minus 32 time plus 40. We need to equal this equation to 20 minus 32 time plus 40. Then we have to isolate this so we can get minus 40. We need to equal it to 0 so we can solve this equation. Okay, now we have 32 time minus 20 because we did this minus this, okay? So we equal it to 0, and then we can start isolating. 32 time equals 20, and then time equals 20 over 32, which actually equals 5 over 8.
So now the final answer. When the velocity is 20 feet per second, the time is 0.625 seconds.